Welcome to Fast Math Solutions on Maths with EJD. In this video, I'll be showing you the proof of the quotient rule. The quotient rule. The quotient rule is a principle in differentiation under basic calculus. And if you, as you already know, or if you did not know, the result of division is called quotient, just like the result of multiplication is called product. So when you divide two things, the result you get is called a quotient. So the quotient rule for differentiation simply, probably by now, before now you've been using that a lot, right? So here I'm going to show you how the whole thing came about. All right. So from first principle, we have that first of all, y equals u of x over v of x. That's actually the quotient to start with. And then you have, u of x and v of x is the same thing as u over v, right? And from first principle, a little change in u and v results to a little change in y. That is, the little change du in u and the little change dv in v results to a little change dy in y. And if that is the case, then of course the next thing, since we are looking for dy dx at the end of the day, so you can transfer y to the other side and you get delta y equals u delta u all over v delta v minus y. And don't forget, when you started out, y was u over v. All right, so the next thing we just do is to take the LCM. The LCM of v plus delta v and v is v into v plus delta v, right? So delta v in this place, we have v, so v times u delta u is what you have here, minus v in v plus delta v, v cancels v and you have v plus delta v left. So you have u into v plus delta v. And again, so since you have u plus delta v, you can, since you have all of these things now, you can expand, So delta y now becomes v times u is uv, v times delta u, that's v delta u, minus u times v is uv again, u times delta v is u delta v, then v times v is v squared, v plus delta v is v delta v. So from what we did previously, we went as far as delta y delta x equals v delta u minus u delta v all over v squared times delta v. So sorry, yeah, we had that, right? We had delta u y to be all of this. So now, since we need delta y delta x, you multiply through by delta 1 over delta x, or multiplying through by 1 over delta x is the same thing as dividing through by delta x. So you have delta y delta x equals all this now times 1 over delta x. All right, so for delta y delta x, it's settled. And for this now, you can multiply it. It's more like you have a over b times you have a over b times 1 over c. So it's the same thing as a over bc. All right. Okay. Let's say a plus. Okay, let me do that better for clarity. So let's suppose that you have a plus b all over c minus d, so to speak. Or better still, let me just follow the actual pattern. A minus b all over c plus d, right? And then you're multiplying that through by 1 over 2. It's the same thing as a minus b all over 2 into c plus d. You can as well just take the 2 up, right? And you have a over 2 minus b over 2 divided by c plus d. That's exactly what we are doing there. So in that case now, delta x is going up because, as you already know, if I ask you the quotient rule, if I ask some people the quotient rule, you can just tell me, okay, y equals uv, and the quotient rule means v tells you have dy dx is v du dx minus u dv dx, so all over v squared. How did it come up? But that's what we are actually doing here. So, and for you to get that du dx and dv dx, and that's why we now multiply. We take this 1 over delta x up, so you have v over delta u delta x minus u delta v delta x. And down here, you still have your v squared plus v delta v. All right. So the next thing we want to do is, since we already have delta y delta x, and for you to get the pure dy dx, you need to take the limit of delta y delta x. Okay. So now that means you have dy dx to be the limit of delta as delta x approaches 0 for the whole expression up there. And again, we know that the limit of a quotient is the quotient of the limits. So if you are looking for the limit of two things dividing themselves, then it means that it's the same as when you take the limit of the top, take the limit of the bottom, and put it together, you still get your result. So what we are doing here is to now say, take the limit for each term all through like that, because the limit of a difference is the difference of the limits, and the limit of a sum is also the sum of the limits. Okay, so we have v limit as delta x tends to 0 for this delta u delta x minus u, limit as delta x tends to 0 for delta v delta x, all over limit as delta x tends to 0 for v squared, plus v limit as delta x tends to 0 for delta v. Okay, so now for the top, no issues. As delta x approaches 0, delta u delta x becomes du dx, and that is why we have v du dx there. And the same applies here. As delta x approaches 0, delta v delta x becomes dv dx. All right. So we have v du dx minus u dv dx. And here, there's no delta x at all. So, I mean, it has no effects. We just have v squared straight up. And then v limit as delta v as delta x tends to 0. Delta v is a small thing. It's a very small value. And then as delta x approaches 0, this delta v is also approaching 0 because it is that small value. So we see this whole part goes to 0. And then at the end of the day, we just tidy things up and we have v du dx minus u dv dx all over v squared plus 0. And then you get the popular quotient rule that you've always known, right? So this ends the proof for quotient rule. So if you never knew the proof for quotient rule that you've always used, this is it right here. So you should be able to do that also. Thank you so much for listening. If you haven't subscribed, make sure to do that, because I've treated a whole series on basic calculus, talking about functions, limits, continuity, differentiation, application of differentiation, integration and application of integration. There's a whole playlist dedicated to basic calculus with about 26 videos or so. So you don't want to miss that. So there you get all the details that you need to know. Thank you so much. Make sure you hit the notification bell so you can always get alerted when a new video is released. See you in the next one.